Okay, 5.4 problem number 9 says no cases of AIDS or infections easily curable by drugs, since all diseases that infect the brain are infections not easily curable by drugs, and all diseases that do not infect the brain are cases other than AIDS. Wow. Okay, so more word salad. So again, the first thing I'm always going to do is try to simplify this down so that it's much easier for me to work with and identify the structure of the argument and kind of how the ideas are being arranged into relationships with one another. And my first step in doing that is always going to be to identify the conclusion. If I can identify that conclusion, then there's a whole bunch of other things that I can then do. So the way I'm going to identify the conclusion, as always, is by looking for indicator words. Words like hence, therefore, thus, consequently are always going to be giving me a heads up that a conclusion is coming at me. And similarly, I'm going to look for because and since and words like that, because those might indicate that I have a premise there. So why don't you go ahead and pause the video and see if you can find any indicator words here that'll help you identify the conclusion. And then once you've done that, go ahead and restart the video. All right, so when I look at this, I see a couple of things. I see the word since, and I see the word and these are important to me. Since is oftentimes a premise indicator. Okay, so I know that what follows since could be a premise. I also know this, that if somebody's offering me a premise, then they must have just offered me, if they're offering me a premise indicator word, then they must have just offered me a conclusion, because that premise indicator is saying, I told you what I just told you because of this reason. Okay, so I know that what comes before the premise indicator word is likely the conclusion. The other thing I see here that's important is the word and, because I know that what and is doing is saying that what the sentence that appears before and the sentence that appears after and are both doing the same thing. This is true and this is true. And all of this is telling me that the very first sentence here is the conclusion. So no cases of AIDS or infections easily curable by drugs. Now, once I've identified what the conclusion is, I can look at the predicate term of that conclusion, and I know that that term is going to appear in the first premise. So whichever of the other sentences has infections easily curable by drugs, that's going to be in my very first premise, and the other sentence is going to be my second premise. And when I do that, I can arrange this kind of mishmash of three sentences all combined up into one. I can arrange them so that they're three separate sentences with the conclusion appearing last, and my major premise appearing first, and my minor premise appearing second. Okay? So now it starts to look a little bit more like what I'm used to working with. But what I have to do is I have to identify my categories of countable things. Okay? So, again, I've got some term complements going on here. So I've got diseases that infect the brain and diseases that do not affect the brain. And that's really functioning like diseases that affect the brain and non-diseases that affect the brain. And similarly, cases of AIDS and cases other than AIDS, those are term complements of one another. So what I'm going to do is I'm going to use D to refer to diseases that infect the brain, and when I want to refer to diseases that do not affect the brain, I'll just say non-D. And I'll use C when I want to say cases of AIDS, and then non-C when I want to say cases other than AIDS. And infections that are easily curable by drugs is going to be I, so then infections that are not easily curable by drugs is going to be non-I. Okay? And when I get this symbolized out, I get this. All D are non-I, all non-D are non-C, therefore no C or I. All right. This looks far more manageable than the word salad we began with, okay? But I still have some work to do, because I remember that those three terms of my argument have to appear exactly the same way two times each, okay? And right now I've got D and non-D, and C and non-C, and I and non-I. So I've got way too many terms here. So I'll just start with the first premise and use the rules of conversion, obversion, and contraposition to see if I can get rid of that non-I, okay? So my 4.4 handout would be handy here. This is the one that has the steps and the rules of conversion, aversion, and contraposition. So why don't you go ahead and pause the video, look at that premise, all D or non-I, and see if you can figure out whether or not conversion, aversion, or contraposition will help you eliminate that non-I. And when you're ready to go, restart the video. All right, so I realize that when I avert something, I change the quality, but not the quantity, and change the predicate term to its term complement. So if I take all D or non-I and change its quality, I'm going to get no D or non-I. Okay? And if I then change the term complement non-I to its term complement, I go I. So now I've gotten rid of the non-I in that first premise by inversion. So I can look at the second premise now. Second premise has non-D and non-C. Now, just as a hint, whenever I see a premise that has, or a sentence that has non in front of both the subject and the predicate terms, I know that this is going to be contraposition, because contraposition is the only rule that allows me to get rid of both of the nons, or to change the term complements on both the subject and the predicate in one fell swoop. And so the way I contrapose that A claim there, all D or non-C, is I just switch the position of those terms so that I would have all non-C or non-D, and then just pull the non on of each of one of those. Okay? And so now I've got no D or I, all C or D, and I don't have to do anything to my conclusion, no C or I. So now that I've got this in standard form, I can go ahead and apply the 5 rules. And if it breaks any of the 5 rules, this argument is invalid. But if it doesn't break any of the 5 rules, then we're good to go because it's a valid argument. So the first rule says, okay, your middle term has to be distributed at least once. So the term that appears in both premises, but not the conclusion, needs to be distributed at least once. So that, in this case, that term is D. Okay. Now I know that A claims, my second premise, they only distribute the subject. So that D term is not distributed in the second premise. But the first premise distributes both its subject and its predicate, right? Because E claims distribute both the subject and the predicate. So the middle term is distributed in the first premise, and I've passed rule number 1. Rule number 2 says that if there's anything distributed in the conclusion, it also has to be distributed in the premise. And in the conclusion, I have C distributed and I distributed. Both terms are distributed because E claims distribute both, the subject and the predicate. So C is distributed in that second premise, so that's good, and I is distributed in the first premise. So I've passed rule number 2. Rule number 3 says I can't have 2 negative premises, and I don't. I only have 1 negative premise, okay? So I've passed rule number 3. Rule number 4 says if I have a negative premise, I better have a negative conclusion, and if I have a negative conclusion, I better have a negative premise. And I do. And then rule 5 doesn't even apply because I don't have a particular conclusion. So this appears to be a valid argument because it passes all 5 rules. But I want to check my work. So I'm going to come over here and label my Venn diagram. And I know with a Venn diagram what I do, is I mark in just the premises. And if this argument is valid, after marking in the premises, I should see the conclusion. And I always want to begin with a universal premise. And in this case, I can just go ahead and start with the first premise because they're both universal. So if I wanted to show that no D's or I's, I would have to shade in the Venn diagram where there could be any D's that are I's. In other words, I want to show it's impossible for there to be any D's that are I's. So when I look here, in order for there to be any D's that would also be I's, they would have to be right here in areas 3 and 4. So if it's true that no D's or I's, then there must not be anything here. So I'm just going to go ahead and turn the lights out. Shade all this in. No D's or I's. There's nothing there. Okay. Now what I want to do is I want to show that all the C's are D's. So I've got to look in my Venn diagram for any place there could be a C that's not a D, and I want to eliminate that now because I want to show that all C's are D's. So here's my C circle here. And I look at 5 and 6 and I think, well, there couldn't be any C's there because those would be C's that aren't D's. And I'm trying to show that it's true that all C's are D's. So I'm going to go ahead and mark this guy in right here and show that all C's are also D's. Now, if this argument really is valid and I applied my rules correctly after marking in these 2 premises, I should see the conclusion statement, no C's or I's. And lo and behold, I do. All the C's are over here in area 2 now because I've eliminated all the other areas where any C's could be, and none of those C's in area 2 are I's. So when it's true that no D or I, and it's true that all C are D, it's also true that no C or I, and it's a valid argument.